Welcome to a slow, beginner-friendly lesson on what libraries and modules are in Python, made for absolute beginners. Take your time. Modules are a small idea with a big payoff. Today we open a new door. Until now, your Python code lived in one place, a single file, or one screen at a time. As your work grows, that one file becomes painful. So Python lets you split code into modules, and gather many modules into libraries. In this lesson we keep it gentle. What a module is, what a library is, and why the world is not one giant file. We will not dive deep into import mechanics yet, that comes next. If the idea feels slippery at first, that is normal, it takes a moment. Quickly, where we are. You finished functions, blocks of reusable work you define once and call many times. That is solid. But all those functions still live in the same single file as your program. When you only have greet, add, and square, that is fine. When you have 30 functions for different jobs, one file becomes heavy. Today we look at how Python organizes work across many files, so you can find things again and reuse them without copy-paste. Hold that image, 30 functions crammed into one file. You finished functions. Now we open the next door, how Python organizes work across many files, so the same function can live in one place and be used in many places. From one function, to many shared across files. Imagine you keep writing Python. You add functions for taxes, functions for dates, functions for printing nice tables. After a few weeks, your single file has hundreds of lines. You scroll forever to find one function. You change a name and break 3 other places. New functions collide with old names. This is not a Python problem, every growing program hits it. The question is, how does Python help you keep things organized as work grows? Every growing program hits this same wall. 3 panes show up in one giant file. First, finding things. A single file with hundreds of lines hides the function you need right now. Second, naming. You run out of clear names, so you invent longer and uglier ones. Third, sharing. If a friend wants your tax function, you would have to copy it out of the giant file by hand, and keep both copies in sync forever. Each pane pushes toward the same idea, split the work into smaller, named pieces. 3 panes, 1 cure, split the work into named pieces. Every healthy program grows. New features, new functions, new ideas. Growth is good. We just need a way to keep it manageable. Growth is good. We just need a way to keep it manageable. Here is the idea. In Python, a module is just a file of Python code. Nothing fancier. You write functions in a file with a .py extension, and other Python code can reach into that file and use what you wrote. A module is a unit of organization. You can think of it as a drawer with a label on the front. Inside the drawer are functions and variables, on the outside is a name. When you want a function, you open that drawer by name. A drawer with a label on the front. Pretend you make a file called shapes.py. Inside it you write 2 functions, square area and triangle area. Nothing new, same def you already know. The only difference is where the code lives. This file is now a module named shapes. Other Python code can ask for the shapes module and use these 2 functions. You did not write any special syntax to make it a module. You just saved Python code in a file with a clear name. Save Python in a .py file, that file is now a module. A module is one file of Python code. Nothing fancier than that. Inside that file are functions and variables you already know how to write. One file, one name, many functions inside. When you have many modules around one theme, we call that a library. Think of it as a shelf where each drawer is a module, all related. Python ships with a big shelf already built, the standard library, full of modules for math, dates, files, and more. Later you will meet libraries other people wrote, which you can install. For today, hold the picture, a library is a collection of modules, and a module is one file. Many modules, one shared theme. Here are a few names from the standard library. Math gives you square roots, pi, and more. Datetime handles dates and times. JSON and CSV read and write those file formats. Random gives you random numbers. Pathlib helps with file paths. OS lets your code talk to the operating system. You do not install any of these, they ship with Python. We will use 1 or 2 carefully in later lessons. For now, just hear the names. These modules ship with Python, nothing to install. When you have many modules around one theme, we call that a library. Think of it as a shelf where each drawer is a module, all related. Shelves of drawers, each drawer a module. Think about the order. Your program runs first. At some line you write import, followed by a module name. Python finds that module and loads it, quietly, once. After that load, The names inside the module are available to you. You write the module name, a dot, and the function you want. Python runs that function and gives you the result back. Import happens before use, every time. Loading twice does not run the module twice. Say it out loud, import first, use second. Type import math. Nothing prints, Python just quietly loads the math module and keeps its names ready. Now type math.sqrt of 9. You get 3.0. Then math.py gives you the number pi to many digits. Notice the shape, module name, dot, the thing you want. You are reaching into the math drawer and pulling out a function or a value by name. Module name, dot, function name. That is the shape. The import word is how your program reaches into a module and brings its names into reach. We will use it carefully in the next lesson. Import is the doorway between your code and the module. Read the dot as inside. Math.floor means the function floor, inside the math module. Math.seal means seal, inside math. Math.log10 means log base 10, inside math. The dot keeps names organized. Many modules could have a function called floor, and the dot tells Python which one you mean. When you read code out loud, say the names clearly. Math.floor of 3.9 gives back 3. The dot simply means, look inside. Ask a practical question. Will you reuse this work in another program? If yes, give it its own module with a clear name. If the code only matters here, in this single script, plain lines are fine. Is the file getting long? Split by topic, one module for dates, one for printing, one for math. Are several functions working on the same idea? Group them in one module. Judgment, not rules lawyering. Split by topic, not by accident. Splitting code by topic is a gift to the person who reads it next. Usually that person is you, 3 weeks from now, at midnight. Organization is a gift to your future self. Tie this back to functions. A function is the work itself, a name for steps you can call again. A module is where that work lives. One module can hold many functions. Another file can reach into the module and call any of them by name, using the dot. So functions stay reusable, and modules make them findable and shareable. You already know how to write the function. Today you learned where it lives when the program grows. Functions live somewhere. Modules are that somewhere. Here is a quiet superpower. Each module is its own namespace, a labeled group of names. Inside one module you can have a function called read. Inside another module you can also have a function called read. They do not collide, because each lives in a different drawer. When you write the dot, you tell Python which drawer to open. This is how big programs avoid name fights without inventing longer and uglier names. A namespace is a labeled drawer of names. Both JSON and CSV know how to read a file, but each does it in its own shape. JSON.load means the load function inside the JSON module. CSV.reader means the reader function inside the CSV module. Same idea, two drawers, no clash. If we did not have modules, you would be forced to invent names like JSON load and CSV reader by hand. The dot does that organizing work for you, for free. Same name in two drawers, no clash, because the drawers differ. Modules connect through names. You write a clear name in one file, and another file uses that name to reach the work you stored there. Pieces connecting through clear names. Quick self-check. Can you say in one sentence what a module is? Can you explain the difference between a module and a library? Can you describe what import does in your own words, even loosely? Can you read math.sqrt out loud and explain what the dot means? If any of these feels shaky, that is information, not failure. Rewatch the matching part. The next lesson will make import even clearer. If any of these feels shaky, that is information, not failure. A module is one file of Python code. A library is many related modules gathered on one shelf. Import is the word that loads a module so your code can reach its names. The dot means inside, module.function picks the right drawer. Functions, which you already know, live inside modules. That is the whole idea in 4 lines. Everything else in this section builds on these 4. Carry these 4 lines into the next lesson. A few small mistakes to expect. First, forgetting the dot. Math sqrt without the dot is not a name Python knows. Second, importing a module but then forgetting to use the dot when you call. Third, naming your own file the same as a standard module, like math.py, that confuses Python. Fourth, expecting import to print something, it stays quiet on purpose. Each of these is normal. Python tells you fast, and you fix and continue. Mistakes here are cheap, Python tells you fast. Next lesson we slow down on import itself. What it actually does behind the scenes. Where Python looks for modules. How to bring in just one name from a module instead of the whole thing. And how to read import lines out loud so they stop feeling like noise. Same calm pace, one new word at a time. Your job today was the big picture. The next lesson is the careful look at the doorway. Next we open that doorway carefully. If you want a quick practice, open your shell and type import math. Then try math.sqrt of 144, you should get 12. Try math.py, you get the number pi. Try math.floor of 7.8, you get 7. 3 small calls, 1 import. When that feels comfortable, you have used your first standard library module for real. If you are tired, skip the practice, the ideas still count. 2 minutes of typing beats 10 minutes of theory. Next lesson we slow down on import itself, what it does not, and how to read it out loud. Same calm pace, one new word at a time. The import statement gets its own short lesson. Thanks for learning what libraries and modules are. See you in the next lesson on the import statement. You have the big picture. Import comes next.